Alright, hi guys, welcome to the second question then. Okay, in this one, in some ways a little more straightforward than the previous one, in some ways. Okay, we've got a function, it's an unusual kind of function, it's a quadratic raised to a trig function. And we're asked to find the exact value. Now, when it says exact value, we've got to find, usually as a multiple of pi or something like that, or a fraction value. We can't just plug this into the calculator and hope to get some sort of decimal answer. Not good enough. So we want to know the exact value of f prime pi over 2. In other words, the first derivative, substituting pi over 2 into that. Now, they give you a hint. Now this hint was given in the actual paper that I got this from, okay, and if they give you a hint, 99.9% of the time you'd use that hint somehow. So the question is, how can we use that hint? Well, I think it's pretty clear that they're talking about taking the natural log of this function here. So let's see what happens if we take the natural log of this function and actually write like they've got here. So we're going to take the natural log of that function. Now if we do that to the left, we need to do it to the right as well. So we've got this. Okay, so it's the natural log of all of that and the natural log of all of the left side. Now this is now saying if we derive both sides. Okay, but let's write it in the way that they've got. So let's say if we derive this left-hand side here, okay, so just carrying on, if we derive this left-hand side, then we also need to make, well, equal to the derivative of the right-hand side. And of course, that's what we're after. So how can we progress any further? Well, we know that this, from this hint, is equal to this. Now, this looks like just a rule, but it's actually giving us a clue as to what we need to do here. We're after this derivative, and that derivative, f dash x, is over the original function. This is going to be really important here. Okay, and equal to, well, how do we derive this right-hand side? Well, we can use one of the laws of logs. Log of a to the power of b is equal to b log a. Okay, where b is the power on this a part here. So we can put the derivative with respect to x, change it to sine x times the natural log of x squared plus 1. Now that's definitely derivable because we can just use the product rule for that. But let's also, before we do that, take this one stage further. Remember, we're after the first derivative, and it's going to be equal to the derivative of this. And if we move this fx off the bottom to the right-hand side, and that's one of the key things about this particular question, is that as you follow through what we've just done, that we need to realize, hey, we've got to get this derivative, but to get f dash x, we also need to then multiply that by fx. So just pause that there and see if you can follow through what I've just done. Okay, and now what we need to do is just carry out the process. All right, so this derivative, I'm going to use the product rule to derive this. So the derivative of sine is cosine. So we're going to have cos x times this natural log plus the derivative of the natural log, which will be 1 over x squared plus 1 times 2x times sine x. Now, all of that is going to get multiplied by our original function here. All of that to the power of sine x. Now, the question is, how much do we want to tidy this up? Not a heck of a lot, because really, remember, we're after what happens when we substitute pi over 2 in. So all I'm going to do in terms of tidying up this part inside this bracket here is just to write this as a single fraction. So we get 2x sine x over that x squared plus 1, and all of that is going to get multiplied by this here. Right, let's see what happens if we now substitute pi over 2 in. Now remember, the cosine of pi over 2 is equal to 0. The sine of pi over 2 is equal to 1. Alright, so what are we going to get? Well, we're going to get 0 times, and it really doesn't matter what the heck this is going to be, because it's 0 times that. Just making sure that this is not going to be undefined, it's not. So this part here is going to be 0 plus 2 times pi over 2 times the sine of pi over 2, and that's going to be 1. In fact, let's just put that 1 in there. So the sine of pi over 2 is 1. And we're going to end up with pi over 2 all squared plus 1. So all of that times pi over 2 squared plus 1. And the sine of pi over 2 is going to be 1, so it's just times this. I'll put that over 1. So let's try and fit this on one screen here. So let's make a bit of room. Okay, so just going to change the color. Let's make it sky blue. So what's happening here? Well, this part here is going to be 0. This here, this fraction, that 2 times pi over 2 times 1 is just going to be pi. So we're going to have f dash pi over 2 equals, so this was 0, so we ignore that. This is going to be pi over this value here. Now I'm not going to try and do too much with that, because I'm hoping that you then see that this fraction here is going to get multiplied by this thing, and the denominator of this fraction, so this is times, is going to cancel. So this part here will cancel with that there, and so we end up with just pi. Okay, so that was the second one. All right, let's move on to the third one.